Maths of the Coronavirus Part 5, Hope for the Future. Key points. In this Part 5 of Maths of the Coronavirus, we're going to look for the things that, as mathematicians, would give us a hint that things are actually getting better, that the coronavirus outbreak is going to end at some point. And we're going to start, perhaps counterintuitively, by looking at this little guy right up a hill. Now, we've all ridden a bike up a hill, and we all know that it starts off fairly easy, it gets super hard, it eases off a bit when you get near the top, you get to the top, it feels great, and then you roll down the other side. In fact, there are 2 points as mathematicians that we're interested in when we ride up a hill. Let's have a look at it in slow motion. So here comes our little guy, and he's getting steeper and steeper, he's working harder, and the first point we're interested in is this point right at the top of the hill. Right there when you've done all the hard work and you're ready to roll down the other side. And you've changed from going uphill and you're about to go downhill. And your bike frame is level just for a second. And so that point in maths is called the turning point, where you turn from going uphill to downhill again. And we'll explore the maths of the turning point in a minute. But let's have a little look at the other point that's important when you ride up a hill. When you ride up a hill, it is steep and hard work. But unless you're riding up a ramp, the steepness isn't going to be the same all the way up. And there's a magic point about 2/3 usually of the way up. Let's have a look. So it's getting steeper for him, but if we see about here, we can start to see that the hill is gradually getting easier to ride up. That is, that it's getting less steep. And you probably know that yourself from when you ride up a hill. When you're going through the steep bit, you're really working hard, standing up on the pedals, thinking, am I going to make it to the top of this hill? And then before you get to the top, it starts to ease off a bit. That is, the steepness or gradient eases off. And it changes from getting steeper and steeper to getting less and less steep. That point in maths is called the point of inflection. And it's very important, as you'll see when we have a look at this guy on a graph. Here's our little guy again, this time on a much more mathematical curve. And we're only interested in the bit where he's going uphill and downhill. So I drag the purple dot across, and across he goes, up and back down. Before we talk about that, let's remind ourselves what the things on the graph mean. The green line there, which is a line that just touches our curve, the hill in red, a line that just touches is called a tangent. And depending on the gradient of that tangent, that is how steep it is, rise over run, that tells us how steep the hill is at a certain point. The number above the rider here is actually the gradient, how steep the hill is. So we start over here and it's flat. A gradient of 0 means flat. The bike is riding along a flat surface. As he comes onto the hill, you can see that number increasing. You can see the tangent getting steeper. He's working harder and harder. He gets to the top. It's flat just for a second before the gradient becomes negative and he comes down the other side. Let's have a look at the 2 key points we talked about at the first part of the video. Righto. So our rider starts over here on the left. Bike is flat. Gradient is 0. Let's have a look at that point at the top of the hill. So here he comes, and there he is. And just for a second there at the top of the hill, the bike is flat again. The frame of the bike would be level. The tangent is flat or horizontal, and the gradient is 0. And you know that experience yourself if you're riding up a hill and you get to that top point. If you've been on a roller coaster, it's the same basic idea. You get to the top, and just for a second, the roller coaster is flat before you go down the other side. Now remember, we called this the turning point. This is the point you turn from going uphill to going downhill again. And the gradient at the turning point is 0. That's the important thing here. The gradient at the turning point is 0 because the bike's flat just for a second. Now, if this curve was a bit wavier, there'd actually be another turning point at the bottom where you went down and you turned from going downhill to back uphill again. And again, your bike would be horizontal just for a second before you went back up the other side. So the important thing here is the turning point. Where you go from uphill to downhill, you have a gradient of 0. The bike is flat. The second point is this point of inflection. So again, let's take him back down and start him again. Watch the gradient as he goes up the hill. Starting to get steeper. 0.26, 0.42, 0.64, 1.37, 1.45, so those numbers are getting bigger all the time, which means the hill's getting steeper. But once I move up to there, I've gone back down to 1.3. Then I go to 1.05, 0.58, and 0. So this point here, 1.452, is as steep as the hill gets. Up to that point, it's getting steeper. The gradient is increasing. After that point, the hill's easing off a bit, and the gradient is decreasing. So the gradient is at its highest point, what we would say in maths its maximum, at the point of inflection. And remember, when you're riding your bike, that's the point where you start to get a bit of hope that this hill is going to finish. That it's no longer going to keep getting steeper and steeper, it's going to start easing off, and there is going to be a top to this hill. That is, the gradient will finally ease off to 0 somewhere in the near future. And the point of inflection, like any point on a graph, has coordinates. So I'll bring those coordinates in. And there they are. 2 across, 2.45 or thereabouts up. That green point there is the point of inflection. That's the point at which it starts to get less steep as we go up the hill. Another way to think about this point of inflection is to think about going up and over the top of the hill as like you're riding inside and then on top of 2 different bowls. So as you're coming up the hill in this part here, it's like you're riding up the inside of a bowl. That's just one of those standard rice bowls you get with Asian food. At your point of inflection here, it's almost like you've switched from going up the inside of that bowl to riding up and over the outside of this bowl, but this bowl is upside down. And in mathematical terms, we say that this part of the curve here, this part of our hill, is concave up, because the concave part of the bowl is pointing upwards. At the point of inflection, we now say that this part of the curve is concave down, because the concave part of the bowl is pointing down. And the point of inflection is where you change from being on the inside of the bowl to the outside of the bowl. So the takeaways from the first part of this video are that our rider going up the hill will encounter 2 points that are important in maths. The first one is right up the top of the hill, right where you change from going uphill to going downhill, where your gradient changes from being a positive number to being a negative number. And that point is referred to as the turning point. And we remember that the bike will be horizontal for a second. The tangent to the curve, that green line we saw, will be flat, gradient of 0. So at the turning point, the gradient, remember we use m for whatever bizarre reason, the gradient is 0 at a turning point. And the second point that's mathematically important is this point here where the hill starts to get less steep. And this point here is called your point of inflection. Now, sometimes you'll see inflection spelt with an X in the middle, so inflexion, but it's the same idea. And at that point, the curve changes from being a bowl in that direction, that is concave up, to being a bowl in that direction, which is concave down. If you like, it's the steepest point on the hill. Now let's have a look at how that helps us look at coronavirus. So here's a little model of the coronavirus. And this model is going to be a bit like playing that old maths game where you have a bus that's going from one bus stop to the next bus stop. And at each bus stop, some people get on and some people get off. So for example, at stop number 1, 2 people get on. At stop number 2, 5 people get on. At stop number 3, 4 people get on and 6 people get off, and so forth. And the trick is to keep track in your head of how many people got on, how many people got off, and then you can figure out how many people are left on the bus at the end. Well, this is very, very similar. We're looking at our coronavirus infection. Now, ours is only going to last 14 days. And each day, a given number of people will become infected. So they're like the people who get on the bus. So that's this column here. Also, on a given day, a given number of people are going to be cured of the virus, like people who get off the bus. And that's this column here. So that means each day there's going to be a change in how many people are sick, total sick currently, like the total of how many people are on the bus. So day 1, 3 new infections, nobody cured, which means I've got an increase in 3. Day 2, 5 new infections, again nobody cured, an increase in 5, which gives me a total of 8. On day 3, 7 new infections, 1 person's been cured, so that gives me a total of 6 new people who are sick, and that gives me 14 as my running total. So you can see how that works. Number of people get sick, number of people get cured, and that affects how many people are currently sick with the virus. So let's put some of that data onto some graphs, and I've got 2 graphs here. The one at the top shows how many people are currently sick on a given day, so that's the orange column here. The one at the bottom shows the daily change, so that's the blue column here. So I'm going to put the first 2 days on the graph. So you can see here we've gone on day 1 a net change of 3, that is 3 people got sick, nobody cured. On day 2, net gain of 5, 5 people sick, nobody cured. In terms of the total people currently sick, that takes us from 3 to 8, from there to there. So that orange line there has a gradient of 5 over 1, because we've gone from day 1 to day 2, 1 day across the x-axis, and from 3 people sick to 8 people sick. So that's the gradient at the start, and the gradient at each day can be seen by looking at the blue column directly underneath it. Let's add a few more days to our graph. Day 3, remember we said our net gain was 6, that's 7 new infections, 1 cured. So there's our 6, and the gradient there is 6. We've gone from 8 up to 14. Let's keep adding. Day 4, day 5, and you can see, just like the cyclist going up the hill, that this is getting steeper and steeper as we go along. Let's keep going. And let's just pause for a sec, because something interesting has happened with the gradient. You can see we were getting steeper and steeper until we got there, but now it seems like we've passed that point in the hill where it's getting steeper all the time, and it's starting to become a little easier to ride up. The gradient is getting smaller. And we'd expect that because these blue columns that represent the gradient, that is the daily change in the number of people being sick, are going down. So remember, this point here where it goes from getting steeper and steeper to starting to flatten out, is called the point of inflection. So it's quite possible that we have here a point of inflection, that we might be tending to get to the top of the hill. We'd need some more data to make that decision certain, but it's a promising sign. The only way we're going to know is to get some more days of data in, so let's put those into the graph. Oh, that looks good. Now I've got a day where it's horizontal, where the gradient is 0, it's flat. Look, there's no column here. That suggests to me we might have reached a turning point, the top of the hill. If we're lucky, the increase in the number of people sick has finished, and there might actually be a decrease. Now, just looking at that graph by itself, I can't be sure whether we've reached a turning point or not, because I don't know if that's going to flatten out and then keep going up, or flatten out and start coming down. Again, just because it's flat for a second doesn't mean that we've reached a turning point. It has to come down if it's a turning point. So let's add some data. And we're starting to come down. And you can see here as we go into the dark blue that we've got negative. What's happening in the real world? Well, we're at day 9. 10 people have gotten sick, but 15 people have gotten cured, which means we're down 5 on the total. It's a bit like 10 people getting on the bus, 15 people getting off. We're down 5, and there it is, down 5, which means our gradient's -5. And as we add more days to our total, out to our 14-day pandemic, you see that yes, indeed, that was a turning point. That was the point at which we stopped going up and started coming down. So that point of inflection there and the turning point there are fantastic mathematical ways of looking to see whether or not we're getting on top of this coronavirus. So does that mean that finding a point of inflection in the graph, or indeed even what could be a turning point where our gradient is 0, does that mean that all of a sudden it's fine? We can stop doing all the quarantine and the social distancing and all that kind of thing? Well, no, it doesn't. Because the maths doesn't guarantee that just because the hill went flat there for a second, that you're at the top of the hill. It could just be a little pause on the way up. If we got there and then we got slack with our quarantining, this could happen. All of a sudden, it could start trending back upwards again. And so what we thought was a turning point turned out not to be a turning point at all. It was just a lull in the process. So just because we've seen a point of inflection or a turning point does not give us an excuse to start getting slack with our quarantine and social distancing. Let's have a look at what that would look like against some real data. Well, here's the current ABC News data for Australia. And here are two very similar charts to the ones I just showed you. There's the cumulative cases, so it's daily count cumulative. And there's the number of new cases each day. Notice I said they're very similar. They're not the same. Because what's missing from this data is the number of people who've been cured each day, because that data is not yet available. So we're always going to be seeing this curve increasing, because we're never taking out the people who got well. That means we'll never actually get a turning point in this graph. It'll flatten out at best, but it won't turn and come back down, because we won't see the people getting better. What we can see, though, is the point of inflection, the point at which the rate of new cases slows down. So, remembering our little bike riding guy, as he comes up this hill, you would say just about there, that is his point of inflection. That's the point at which it stops getting steeper and steeper and starts to flatten out a little bit. And similar to the graphs I just showed you, if you have a look at the number of daily, the new people getting sick each day, you can see that that correlates very nicely with that point there. So the number of people getting sick each day, the new cases, increases. So here's our guy coming up. he got a kind of trick from the hill there, short respite, then it went, oops, and then it started to ease off a little bit. Now remember, this is not him coming downhill, this is the gradient getting lower and lower, as you can see here. It's not him coming downhill, it's the gradient easing off, which is a great sign for coronavirus. Hopefully, we'll be able to see data soon that includes the number of people who are getting better, and we'll be able to see that turning point in the graph and the total number of sick people in the community coming down. And it seems that huge numbers of people are getting better. We've only got a total number here, not a day-by-day breakdown. But if you have a look at this little chart here, you can see that's the number of people who are currently sick. That's the number of people who've recovered. And a very, very small amount of people, unfortunately, who are deceased. So hopefully this little video has given you an introduction to turning points and points of inflection and showed you how to use them to understand the data and potentially look for signs that this coronavirus epidemic is coming to an end.